Talking about centripetal force. And what it is an inward pull keeping an object in orbit. Okay? So what that means is we've been studying these objects and that marble going around and around and around and around, and then when you open it up, it's going to go out, right, everybody? An object wants to go in a straight line. It wants to keep its motion, okay? So some cool activities that you can do with this, and let me just see if I can, what's that do? Oh, I don't want that. I want to do this in video. All right, so let's just set this like this. And Molly, you're kind of in charge of running that, making sure it can be seen. So what I got here is a bucket of water. Everybody on the board, can you see that? There's water in there. Okay, I don't know, it's probably not perfect. Why don't you videotape me right here? We don't get the board in the background. So you probably have seen this trick. Maybe you haven't. It's really pretty cool. So I got some water in here. I'm actually going to dump some out so I don't bust it. Because this is a lab. This is an activity that has definitely gone haywire on me before, because you're depending on a force. The force is not my hand strength. It's the bucket. So the bucket actually has to hold up. So what I can do is I can swing it back and forth, and I get going slowly, and then I go around, and the water stays in the bucket. Listen this. If I go slow, some of the water literally falls out. So there's a balance between my inward pull, the centripetal force, and the force of the water or the object pulling away. You guys with me on that? So again, this is the same orbit. If there is not enough outward force or motion or inertia, there's not enough of that, then the gravity is going to pull it inward. Does that make sense? If there's too much, and I start to spin it faster and faster and faster, at some point, what's going to happen to this bucket? It's going to break, and then what's going to happen? It's going to go flying, right? You guys with me on that? Which, believe me, in my 15 years of teaching this, it has happened. That's what this is here for. Okay, so this is kind of the same idea. You get an object and you set it on here. Something that you don't care about breaking. Actually, you know what'll work really good? My wallet. I'll just set my wallet on here. Same exact setup. So anybody at home, there's a few people at home. Okay, same thing is I just swing it like this. And it's not going flying, is it? So there's nothing containing it. That's the outward force. If I go slow, gravity at that point is too fast, isn't it? It's pulling it down, and the force out is not strong enough. So that's centripetal force. So there's got to, again, going back to planets, there's got to be a perfect balance between, I can take this off now. Actually, we could turn that bugger around. I want to get rid of that. I don't know how to. Oh, well. Okay, so there's got to be a perfect balance of the speed going around and the pull inwards. There's always a pull inwards. Pull in, pull in, pull in. And we call it also centripetal acceleration. And if you think back a couple days, remember what acceleration meant? It meant a change in velocity. Either change in speed or change in direction. But what's happening with this thing in a circle?
It's not changing velocity.
It is changing velocity. Why? Is the direction the same at all? Hey, look at this, guys. If I get that bucket and I swing the bucket and I swing too hard, at some point, what's going to happen to us? It's going to break and it's going to go in a straight line, right? Because that's how objects want to move. But it's not doing that, meaning it's changing its velocity all the time. It's changing its direction continuously because there is a pull into the center all the time. And in planets, it's gravity. In both of these cases, it's my arm, isn't it? Okay? So could you do that exact activity and then let something rip and show that's Newton's first law? An object in motion will remain in motion at a constant rate in a constant direction? Sure, you could do that. Okay, so there's tons and tons of activities in here for you to do. You just got to look at it. All right? I also have books with really, really cool activities. In the back, tons of activities. So you guys do that. All right, so I'm going to shut that down.